Our guest today is Pawel Osterreicher, the CEO and founder of ReSpo.Vision. ReSpo.Vision disrupts sports with the help of artificial intelligence. Their computer vision algorithms capture detailed 3D positional data from sporting events and turn it into practical insights and visualizations, providing sports clubs and sports media with an unmatched depth of knowledge. They work with elite football clubs such as Paris Saint-Germain, as well as the top media companies. Before founding ReSpo, Pawel was the chief revenue officer and board director at Deepsense.ai. Before that, he spent 7 years at the Boston Consulting Group. In this episode, we talk about the evolution of sports analytics in a relentless pursuit of excellence, new powers enabled by AI, and ReSpo breakthrough work in computer vision. Pawel, ReSpo.Vision is a sports analytics company. So, how about we start with the history of sports analytics as a field, the evolution, and what computer vision can bring to the table? How can it advance the field further?
Yeah, sure. Happy to elaborate. Well, there's lots of things going on right now in the sports analytics world, but I think it might make sense to start with the an overview, like historic overview. Well, essentially for decades, sports analytics were synonymous with statistics. Statistics usually gathered manually by observers, by officials, all that kind of stuff. When I'm talking, football, I'm talking passes, shots, saves, dribbles, falls. When I'm talking basketball, I'm also talking about 3-pointers, 2-pointers, assists as well. No, specific set of statistics for particular sports. Well, that was gathered, that was then aggregated and used for some sort of analysis. And that was the reality for decades. The technology in technology starting to be introduced in 90s, in 2000s, allowed for more sophisticated analysis. And then we get to advanced statistics, and finally we get to something which we call event data. Event data is essentially trying to understand a pivotal moments of the game and then shed some light on what's going on. Again, I will be using football, which is known in US as soccer, as an example. Well, event data in football is an actual what was going on with, for instance, in particular moment of a particular shot, like who was standing where, who was blocking, who was attempting to block, who was passing, who was creating some distortions, etc., etc., etc. So this is what happened like 10 years ago, 15 years ago. It was technology enabled because you had to have a proper camera recording. You had to have a workflow of specific persons, watching that, verifying that, pinpointing particular things happening. But it was like a simple technology. It was nothing too special. Well, let's move to more recent times. And around 5 to 10 years ago, there was another revolution in sports analytics. This time enabled by, well, broadly speaking, data science and to a certain extent artificial intelligence. Well, we started doing tracking of movement of players, tracking of movement of the ball, and this enabled a broad new set of data. It essentially applies to all these sports, not only football, but also, again, all other major sports. And what I mean by tracking, well, as I mentioned, it's a automated system that records and follows and notes the movement of particular actors in a game, which are players, ball, referees to a certain extent. So tracking enabled a new set of data, and obviously those data can be mined, can be analyzed, can be aggregated, can be compared, etc., etc. And right now we are in the era of tracking, so to say. Yeah, so not only statistics, yeah, they are present, not only event data. It's still interesting, but now more and more so tracking understood as two-dimensional tracking, which is something which already is now, there are multiple providers, and even more recently, a 3D tracking, three-dimensional tracking, which is different from 2D tracking by an inclusion of z-axis, which is the height. Yeah, so we don't only see everyone as a dot on a plane, but we also see the third dimension, the height of the ball, the height of the players, the particular body parts, and their position in a three-dimensional space. So 3D tracking is the most recent advancement, and this particular advancement is directly fueled by specific part of artificial intelligence, which is called computer vision. Yeah, it's obtained by automated optical systems, fueled by deep learning models who are assessing and gathering the 3D tracking data. And this brings me, to what we and my company at ReSpo.Vision offers. We are experts in 3D tracking, the most recent, the most modern and advanced sports analytics tool. Yeah. So this is how we position ourselves, and this is how the history of the tracking and sports analytics, evolved over time.
So from simple statistics to now advanced tracking of player movements, of player positions, what is the benefit of that tracking of the players during the game?
Yeah. Well, obviously, the easiest answer is it's more data. Yeah, but as we all know, and probably listeners to your podcast will know very well, it's not only about the volume of the data. Sometimes it can be even you can be worse off with more data that you cannot crunch than with a smaller subset, which is meaningful and is easily turned into insights. So obviously the sheer volume doesn't mean anything, but it is there. Yeah, it has to be mentioned that if we go back 20 years and we ask ourselves how many data points was gathered from a particular sport event, such as a football match, it was probably a few dozens, like, this pass, this shot, this foul, this tackle. Right now, our optical tracking system, 3D tracking system, gathers 200,000 data points, but per second, not per game, which is, it's close to 1 billion data points per second, because, because we capture over 50 body parts, 60 times per second, three-dimensional coordinates of each, and you have 20 plus players, you have the ball, etc., etc. So the sheer volume is there, but the real trick is, how we can leverage this data. So the tracking, 2D, but especially 3D tracking, unlocks certain analysis, especially analysis linked to the body movement. So the way players run, the way players behave, the way players interact with each other. So right now the holy grail of again, I will be referring to football. The holy grail of football analytics is pressing. It's very important to be pressing efficiently, to be pressing relentlessly, to be doing it even if you just lost the ball, to do it as soon as possible, because then you don't allow your opponent to spread the wings. There's a whole philosophy around particular coaches, managers who are pushing the the theory of pressing. But again, in order to do that properly and in order to implement it, it's quite important to know when it happens, how often it happens, what are the metrics around it, like was my pressing better or worse than my opponents, etc., etc. So this is what we enable, because in order to calculate such things like pressing, you have to understand the body, the differences between your particular body part as your upper body and the opponents whom you want to press, again, his or her, depending on the type of the sport, body. So only thanks to the precise measurements, such as in 3D tracking, we enable ourselves to better understand crucial metrics. Again, pressing. Pressing is an example. There are more metrics to that. There's like a body orientation metric, the number of looks a player makes before attempting a pass. Right now, no one has a clue whether let's take football example, for instance. No one has a clue what made Kevin De Bruyne or Xavi or Iniesta a great great midfielder with a great vision. Was it skills, technique? Was it his smartness, brains, creativity? What was that? It was like intangible. Like we knew one person was better than the other, but we didn't know specifically why. And now we can introduce certain metrics, such as how many times each player looks or scans the area before he or she makes a pass, and then try to correlate it with with another metric, which is like success ratio of passes, or conversion ratio from your passes to successful goals or something like that, and then be able to use this information. At the end of the day, we want to use this and the other information to gain competitive advantage, because at the end of the day, this is what professional sports is about. So in order to gain competitive advantage, we find more and more practically useful statistics that explain the reality, the complex reality, and then we try to use them to help our team win. And that's the thing essentially.
Professional sports are about relentless optimization.
Yes, they are.
The whole idea of the field is geared toward this. This is the reason for their existence, to beat the records, to establish new records and beat them again. So you advance this field with the new set of knowledge or new set of insights they can get. How do you productize this? What kind of product you offer to them?
We consciously approach the problem from a technological perspective. We believe that there is so many things to be done from the technological perspective that it deserves a very focused, very rigorous approach, analytically speaking, but also algorithmically speaking, because we have to build the algorithms, the data harvesting algorithms first, to obtain the data. So we are very much focused on that. It means that we took more of a deep tech approach. Yeah? We're building an R&D solution, heavily leveraging things like computer vision in order to create a product with a technological advantage. So our product at the end of the day will be and is data and insights. As the very first output of our systems, we can obtain, or we are obtaining the raw data. What is raw data? Well, positional data about the players and the ball. Is it useful? Partially. A competent recipient, such as a club with an analytics department, can make use of such data. Clubs or federation or league or a sports data company. There are many competent institutions in the sports world, and obviously that was our first product. Like we built a system. The output of the system was positional data, and fortunately there were interested parties with a modeling muscle that were interested in getting this data and using it to enhance their own models, usually based on event and 2D data, which I mentioned before when I talked about the evolution of the sports analytics. So those were our first customers. Interestingly enough, the first customers were recruited from the world's very best clubs and federations, because those were the ones with the most advanced models and advanced capabilities. So our very first customer was Paris Saint-Germain, a huge leading European club, whose representatives were the judges in the startup accelerator that we took part in. That was our very first customer. With time, we started turning the raw data, which we were still able to sell to competent partners, into what we call process data. Process data is not only coordinates, parameters, but also statistics and insights. And this is the process that we are in right now. We are churning more and more process data in order to make it easier for more mass market customer, in order to have this mass market appeal of our analytical solution. At the same time collaborating both with the competent partners with regards to the raw data and process data customers. So this is essentially what we are offering right now. We do have another R&D effort going on, but I think I will try to touch it upon when we cover more of a sports media vertical, which we are also in very active in.
Yeah, and this is actually the next question I was going to ask you. It's clear how you can offer your product to clubs that have that analytics muscle and federations, I assume. But how about media companies? I don't think you can expect them to have analysts to go through the raw data.
Oh yeah, that's why the product for the media is visualizations. Is visualizations which we have to do on our own. Yeah, I totally understand that, and this is also the feedback that we have received when we were gathering it with regards to what's interesting for the media companies. So here's the thing. So we are capturing so many data points. Like I mentioned, 200,000 data points per second. The typical data point that we capture is left shoulder 3D coordinate within the boundaries of the pitch 60 times per second. Same goes for the left eye. Same goes for the chest. Same goes for the a particular joint, like left knee, right knee, etc., etc. So this is the type of coordinate that we're gathering. The good thing about our solution is that we are able to capture the data with accuracy measured in centimeters, which means they are generally very accurate. So since they are very accurate, nothing stops us from being able to recreate a real life event, such as again, football game, into a virtual reality, such as something similar to a video game of a football game, yeah, which think about franchises such as EA Sports FIFA or Konami Pro Evolution Soccer, yeah. So we can build a real life event in such an environment. What for? One, you may ask. Well, obviously, if you have a real thing, then you can watch a real thing, but there are limitations into how you can interact with a real thing. First of all, you have to pay money to be on a stadium with limited capacity. Secondly, you will be able to watch it from a specific viewpoint. If you're in a stadium, this is the viewpoint of your seat, but if you're watching it in a TV, a viewpoint of a camera or cameras that are essentially recording the game from afar. But if you recreate the game in a virtual reality, nothing actually stops you from showing the perspective of a particular player. Like imagine rewatching a goal from striker's eyes, like literally what he or she has seen just before scoring the goal. Well, it is possible because we recreate the whole thing, the pitch, the stadium, the players, the ball. Yeah. So the only challenge right now, which we are working on, is the quality of the reproduction. I mean, yeah, well, it's easy to reproduce it as it was a video game from 10 years ago, but it's not that easy to reproduce it as it's a recent video game. Like it actually requires a lot of game development effort, and we are doing it right now. But then again, the promise of the product and the potential of the product, I do believe, is huge. It's so obviously and I covered only one of two major use cases. The use case I covered, instant replay highlights from a player's perspective or from literally any perspective that is immersive, insightful for a viewer. So think about, I do believe so that in a year or 2 years from now, many sports events transmissions, be it in TV or in the internet, will be enhanced by such a perspective, point of view, additional immersion, as I just mentioned. And this is like the use case number one of technology that we are building for sports media. The use case number two may be called with a little bit of grandiose words, metaverse, sports metaverse. I mean, obviously the words the word metaverse is probably is not the sexiest word right now. It was a year ago, but then again, we can call it virtual reality for what that matters, because since the game is recreated, we can also sell virtual tickets for the game. If we are talking about integration with certain hardware, again, whatever hardware it will be, it only has to be good. It only has to be immersive, and if it is, then nothing stops you from selling a additional 20,000 tickets to Manchester United game to a Malaysian fan base, and they will sit in Kuala Lumpur or wherever they live. And at the same time, just by wearing a headset or a specific hardware, they will be able to sit on the stadium and watch the game almost as if they were at an actual stadium. They can even purchase a little bit more expensive ticket and then be able to watch a replay of the scoring situation from within the pitch itself. I mean, again, what stops us from allowing them to just teleport themselves onto the pitch? Like nothing stops us because it's a virtual reality. I mean, and there's no limitations how many people can fit on the inside of the pitch. I mean, it's purely virtual. So this use case is a little bit more complex, and it won't happen next month because it will not only requires the development of the graphics, which we are working on, but also integration with specific hardware set. But again, it's extremely exciting. I mean, without using too big of a word, I can say that we are looking at specific avenues for the future of sports broadcasting, the way people will experience sporting events. So yeah, so that's about the media.
On that note, about sports broadcasting, there are several attempts to bring 3D, I would say, experience when they bring 3D camera and they plug it to a VR headset to give you that experience at home of being at the game actually. How do you see those efforts? I mean, I see the clear difference between them and what you're talking about. You're talking about, not, first of all, not using the 3D cameras equipment, not necessarily using it. You can recreate, I assume, the game from the video streams, the multiple video streams that are already there. Plus, you're talking about being able to experience that game from any perspective, not only from the perspective of that specific camera set up at a specific place, which are clear differences, but still interested. What do you think about the current attempts at bringing that immersiveness to the sport events?
So there are two things which I believe are worth mentioning. First is, as long as we have simple, poor hardware, there nothing can be done. Only if we invent something with some hardware which is significantly better than what has been used so far, we can talk about successful implementations. And I'm aware of that. With current hardware, it will be borderline impossible to achieve the the effect I was mentioning, the immersion, the feeling of of being at the stadium, not just some random simplified blocky recreation of it. Yeah, and this is generally a problem of broader metaverse trend. I mean, if Mark Zuckerberg comes out and says that big revolution, my avatar has now legs, this is more ridiculous than actually pushing any boundaries. So yeah, what was problematic with every single attempt so far was the poor hardware integration and poor experience that resulted from it. So what I'm aware of is that I'm not talking about something which will happen again month, 3 months, 6 months. It will require a good enough hardware, and obviously a good and a little bit more. But the hardware definitely is the challenge here, and it wouldn't make sense to push a ready product for a subpar hardware, because that would ruin the experience. It will be just again, it will be hard to take it seriously. The second part of the picture is an actual recreation, yeah, and the recent attempts usually required some form of a multi-camera 3D cameras calibration. Recently, thanks to the to revolution in software, which was fueled by revolution in deep learning, so better software based on deep learning started to appear even in our everyday items such as iPhone. I mean, like, well, unlocking your iPhone or your phone, whatever it is, with your face is like you weren't able to do that 10 years ago because there was no technology. But like 3-4 years ago, the technology appeared thanks to, again, those are neural networks that actually are trained on millions of human faces and then are very, very accurate in recognizing your particular face. Similarly with the technology that we'll be using, I mean, every next generation of the software which is optical tracking, computer vision based, is more fortunate than the previous one, because it can as they say, I'm standing on the shoulders of the giants. Yeah, well, we are building the foundation, and then it's easier and easier to to build an actual working solution. So as simple as it may sound, all the previous solutions were unfortunate in a way that they weren't there wasn't strong enough software and solutions enabling the difficult use case, helping to enable the difficult use case, because we are talking about difficult use case. A accurate optical tracking of fast-paced objects with limbs, bodies, etc., human beings, is an extremely difficult task. It's not something that we can do with a simple camera or some small amount of RAM. It requires gigabytes of terabytes of memory. It requires specific graphical processing units, etc., etc. And only now it starts to become possible. So the difference which I'm seeing is that well, only now it makes sense to actually tackle it in a commercial fashion, in a like build a product out of it, because up until now it was R&D attempts trying to push the boundaries, but very hard, very difficult to actually make it workable. I'm talking about previous attempts. So combination of those two things, yeah, that I mentioned. First of all, the combination makes me positive about the chances of implementing it. The hardware, which is getting better and better with the new generation headset, recent generation headsets, and the software based on the deep learning solutions and algorithms are, I do believe so, now of sufficient quality to pull it off. And if you join it together, it means, well, right now is the time.
Right. And it will take a few more years for both the hardware and software and the compute for all three parts to catch up.
Yes.
We will see better VR headsets, and then it's going to be exciting to see what we actually can do and how we can immerse ourselves into this live sports without leaving the comfort of our couch. That's going to be awesome.
Yeah, I agree.
What are your most favorite examples of ReSpo.Vision being used at your customers?
I will give you one or two examples from sports clubs, because I think they speak to the imagination the best. So we are doing 3D tracking. Okay? We are helping our partners and our customers understand the human body movement, the physics of human body, etc., etc. The moments, the situations in which this particular understanding, like the full entirety of human body, helps solve particular problem, is something where is a moment where our technology shines the most. One of such examples was when we were working with PSG, our first customer. They had this specific training challenge, coaching challenge. Well, they believe the player, the defender, the central, for simplicity, let's call him central defender. When the attack is incoming and the defender is in a defensive stance, ideally the defender shall have his or her body oriented towards an incoming player, ideally the one he or she is supposed to mark, but the defender shall control the ball with his eyes and head. So essentially we're talking about person who is ordered to stay in front of the incoming player, the one he or she marks, like ideally be oriented against his or her body so that he can move quickest in a response to the potential movement of the attacker, but at the same time should have his eyes on the ball, and the ball might be in totally different place. Like the ball can be on the right hand side, like on the flank, but you will be still defending against incoming attacker from the middle. So that creates a challenge. Yeah, you have to have your head oriented in a different direction than your body. Obviously, subconsciously, humans in most of the cases orient their head and their body in the same direction, because that's the easiest thing to do, the subconscious thing to do. So our data was used in order to calculate the angle of your upper body and lower body orientation, which we can, because we capture shoulders, left shoulder, right shoulder, left hip, right hip. We can calculate the line between them and then measure the angle between this line and the sideline, for instance, the sideline of the pitch. Yeah, we have the angle, the orientation of your shoulders, of your hips. Similarly with the head, we have the eyes captured. Yeah, and we can see where the player was looking. Yeah, and we used that for coaching purposes in order to train the players. Yeah, well, in this particular, we were analyzing. They were analyzing particular situation, game situation from the actual game, using our data. Well, in this particular situation, my friend, I'm talking to the defender right now, positioned your body properly. I mean, you were facing an incoming attack, but you did not follow the ball with your head. You were zooming in on the player you were about to mark. And that was a mistake, because you have no idea what was going on with the ball, whether the pass was, whether the cross was being made, or whether the player was dribbling in the mid to the center of the pitch, and that created a vulnerability, because if you knew, you would move, you would and you should move to the left to cover this and that. Yeah, I mean, those are very. It took me a little bit to explain that, but those are very specific analysis. But trust me when I say that it enables a very detailed and very pragmatic, very very important coaching situations between the manager and the coach or the trainer and the player. And there are lots of situations like that where you have to understand the entirety of the body or human body movements in order to be able to to find out certain patterns, certain behaviors.
We're talking about granular optimization. The last 0.1 percentage points of the performance. So we need to dive deep into the very, very granular things that's happening on the field and with the players. So makes perfect sense. Let's now dive under the hood of your system and talk about the AI systems and modules that are used in your product.
Sure. Essentially speaking, we build a system consisting of many modules tackling different stages of let's say data gathering, data analysis, and I will just briefly mention the most important ones. Well, first of all, since we want to capture the detailed coordinates of players, etc., we have to understand where we are looking at. So where the camera is looking at. We don't want to rely on a pre-calibrated cameras, like the cameras that we have to personally supervise, set, and control the direction. We want to be able to use any camera, like broadcast camera, because that allows for a scalability of the solution, that our solution can be used, regardless we set up the cameras or regardless we were with our cameras at the stadium. So in order to do that, we have to be flexible in the recognition of the of where the camera is looking at. We call this module pitch geometry because essentially the way the camera realizes, the system realizes where it's looking at is by the pitch geometry, the lines of the particular pitch of particular sport. So we train a system for football. We train with thousands of images of a football pitch with the lines. And there are specific lines in the football pitch. There is this outer line, there is the box, the line, 5 meters line within the box, within the penalty box line, etc., etc. So those are specific lines which we train the system on. And similarly in other sports, in basketball it's specific and also very regulated. So the whole thing is is to have thousands of as easy as it seems, it's not easy, but you have to annotate thousands of images of stadiums and pitches, and then train the model on it, so that when it looks at something brand new, it quote unquote understands which direction it's looking at. So whether we are looking at the home team half or the away team half, etc., etc. So that's the pitch geometry thing. Once we know what we are looking at, I mean the algorithm, we also have to include the camera optics part. This is a tricky because as I mentioned, we build our system with a premise that we don't want to we will not always know the camera parameters, because those won't be our cameras. Those may be the camera of of someone who records Dutch second league game, and we won't always control that. Actually, in most of the cases, we won't control that. So our system has to automatically understand the camera optics. The camera. Why is that important? Well, the further we look into the pitch, the more distortions are happening because of the way the optics of the camera work. Well, a player very far away from the camera, which is 10 pixels away from the ball, which will be the difference between him and the ball will be very different than a difference between a player who is in the first plane, and there is a 10 pixel difference between him and the ball, because of the distortion, the distance, and the way the camera optics work. So we have to have a module that calculates the camera optics and then corrects for distortions, taking into consideration the distances. So that's the second system that we have. Then obviously is a player tracking. It's easy, very easy with current, let's say, framework libraries. Player tracking as in object detection. Well, who is a human, who is a what is a ball, and what subset of humans are players, what subset are referees, what subset are non-player, non-referees, like spectators, or all the other stuff. This is easy. What is hard is identification. Yeah, so knowing which player is who, attributing the name of the player. Obviously, we are using several approaches to that. We're using OCR, trying to find a number on a player's shirt, and team detection, detecting the particular team by the colors, because in most of the cases the teams have significantly different colors, and then match it. But sometimes sometimes players are occluded. No, not always the number is visible. Maybe it's dirty or something. So we have to use several other attempts, such as recognizing player by the mesh, like the general outlook, by specific attributes such as the color of the boots or the haircut, or even by some smart heuristics, like we already know 10 players from this team, so the last remaining player have to be this guy, because we know the lineup that is on the pitch right now. So that's another that was the third module, the player tracking, player identification. Then we have the creme de la creme of what we do, which is body pose skeletal tracking module. So essentially, once we have the guy identified, we have to capture the 50 body parts that we measure in 3D. So we run body pose skeletal tracking algorithms. On top of that are two further modules. Analytical module, well, we have the data, let's do something with the data, some insights, and visualizations. We have the data, let's visualize it in a different engine, virtual engine. So those are the AI systems modules that we used. Majority of those, especially the first ones, pitch geometry, player tracking, player identification, rely heavily on neural network architecture of what can be called computer vision systems. And this is essentially the speciality, the specializations of what we do, because those are the most difficult, the most in-depth systems that we use.
That's a lot of work you need to do to come up with the insights, or at least with the raw data and then insights that you're coming up with. And this is really impressive. What kind of precision types of statistics you look at, and where are you in terms of the precision of the techniques?
We for the visible objects and players, we are capturing. So as I mentioned, player object detection is easy. We're like 99.8, 99.9. Player identification is a bit more difficult. So this is something where our accuracy is 95, 96, 97, depending on the particular game. There is a room for improvement here, obviously, and we as much as we would like to move towards further things like further sports, etc., we still have to there still have to be work done in that department. When it comes to the output accuracy, which can be measured, which is no longer measured in I was talking about, like, say, coverage accuracy, but when we talk about output accuracy, then we are really good at it with it. I mean, the final output of the players and their body parts that we have captured, we measure with accuracy less than 10 centimeters. Yeah, so we very well know what is where, and we are able to position it within the football pitch. So fortunately, the final result is of high accuracy. But of course, as with any computer vision system, if you really want to, you can improve it for years. I mean, and find some small improvements, small tweaks, some small better libraries that you can use to further improve your results. The real trick is with finding a balance, because quite often those improvements come at high cost, be it a compute cost or essentially investment slash operational cost. You have to essentially code it, build it. So we do believe that that there is a trade-off, which probably is somewhere between 95 and 99%, where the quality is sufficient and the scale becomes more and more important. The ability to compute thousands of games a month instead of just doing it as accurately as you can with all the resources you have. So that's the current challenge as a company that we are facing. Moving with a high accuracy of particular games into a essentially a harvester of games which can process thousands of games a week, a month, stuff like that. So those are really interesting dilemmas, especially if you start looking at compute costs, at cloud costs, and stuff like that. So interesting stuff. That's why I use this analogy with the answering your question about accuracy, because obviously one can optimize accuracy probably for infinite amount of time, but the real thing is to create the product out of it which works and which is scalable and which is repetitive and cost efficient.
It is always a trade-off, and gains eventually become asymptotic. So you throw more compute, you throw more efforts, and you achieve less and less. So 100% agree with you. Do you have to have a human in the loop, or the performance of the algorithms is already superhuman?
Depends on the quality, yeah. So and depends on the customer preferences. So if we are for particular analysis, if you are now, for instance, interested in analysis where the precision must be extremely high, we use a human as a final output corrector. But for 90 to 95% of the cases, our customer cases, we don't use human, because the data is usable and the data is good only for the most difficult, only for the most precise use cases. There are a few use cases which require extreme precision. Human in the loop is being used only for the most demanding customers who require the accuracy measured not in centimeters, but more like it cannot be the error cannot be higher than 3 centimeters. In that case, we have to or 3 or 5 centimeters. In that case, we have to make sure that everything computes in terms of a human body, in terms of the visuals versus the data, etc., etc.
To train the system, you had to collect and label, I presume, quite a bit of data. How did you go about it, especially at the very beginning when you were just starting? You didn't have all those relationships with the clubs to have the information from them. So how did you go about building your initial training data set, and how this process of data collection, labeling changed over time?
We quickly established partnership with clubs, and hence the access to the data, which helped us quite a lot, even at the very beginning. So that was a good move. That helped us immensely. We had and still have a significant annotation team and partnerships, which we use to essentially create a ground truth and the let's say the basic level of items that we train our algorithms on, such as the pitch lines that I mentioned, the pitch geometry model. We have to manually annotate thousands of pictures with a pitch visible in order for the system to learn to detect lines, particular lines. Yeah. So we did all that, and we're still doing that because there are more and more use cases, more and more sports, etc., etc. At the same time, we are also right now, like next week, we are having another round of ground 3D skeletal tracking ground truth collection, which is we'll set up a few cameras, we'll calibrate them very precisely, like we will know where they are looking at. They will be very stable and just not moving. And in the middle, we will have people running around, recreating actual professional football players, recreating a football situation from a football game. And by doing that, we will capture a ground truth for the 3D skeletal detection, which we will then use to further enhance our algorithms. So this is if you this is a never-ending process. because there are more and more use cases, again, more sports, additional data that is always important and helpful, because again you make your system more resilient for edge cases. But yeah, this is the only way to approach it. I mean, since there are no available data sets of quality, we have to create them ourselves.
Those folks that run in your mock football games, they wear sensors, so you have the ground truth of the body positions.
Yeah.
Okay, gotcha. And you had to build these data sets from scratch sometimes. What were the most important lessons learned from dealing with the whole data pipeline?
The first lesson was the one that I partially mentioned. It's, one may call it 80-20, and one may call it a trade-off, which is a difficult technological problem can be this is some sort of an anecdote, but if you define a very difficult, cutting edge, bleeding edge type of a AI problem, you can have a team of 3 or 5 persons working on that problem indefinitely. I mean, for the next 20 years, because there will always be improvement. There will always be things that are worth checking or seeing. Maybe they will improve the accuracy of the model, or maybe they will decrease the compute, or maybe they will make it more flexible, resilient, etc., etc. So the real challenge is in prioritizing and telling yourself, well, okay, enough is enough. I mean, it's good enough. I mean, no one else has such quality. We can move on to, or this team can move on to the next challenge. So that was the single biggest challenge. The second biggest challenge, connected with what we are working on and what are the future areas in which we want to test and challenge. The second learning was with approach towards edge cases, and let's say, okay, so for instance, for us, the challenge is that we build a system that can work on any subset of cameras. Yeah, we have 3 cameras. Okay, that's good. We have 2 cameras. That's good. But sometimes we only have access to 1 camera. If we have access to 1 camera, we still can do the analytics, which makes us quite unique, because most of the competition have to have at least 2 or 3 cameras in order to calibrate the system. So the system is trained differently. It requires 2 or 3 different positions of measurement, because this is the way it's built, and only then they calibrate the coordinates. We trained our system to understand the 3D depth from a 2D input, because essentially a camera input is a 2D input, X on Y matrices with pixels. Yeah. So sometimes we have to deal with only a single camera input. In a single camera input, the most difficult thing is, okay, what happens to invisible, or the players that are not visible in a particular frame or a particular sequence of action. They are like outside the frame, the defenders, the goalkeeper of the attacking team, etc., etc. Well, we still want to have their positions. I mean, why not? Well, we want to have the comprehensive data. Yeah, what with them? Well, and those are the challenges that are interesting and require creative solutions. So right now we are starting to work on what we call ghosting algorithm. It is an algorithm that will predict the behavior of player who is not visible in a particular frame. Yeah, obviously, a barbaric primitive approach to ghosting would be just to assume that I saw him or her in t-5, and when I see him in t+2, then he or she has to move with a linear acceleration, or with some sort of assumption with regards to the movement between this point and that point. But this is a very primitive approach. Yeah, I mean, people don't move like in the line all the time. So we are right now experimenting with using reinforcement learning module or model, essentially, to estimate the movements of the players, like to give them we love that we are giving them a little bit of a soul and brains to just run around and simulate what's going on in actual game. So this is the second type of challenges. Yeah, we have some we made some design choices, such as we want to have a full coverage and we want to be able to use one camera. Well, then what with the players out of the frame? Well, yeah, simulate them. Well, so we have to do that. And how to simulate them? Well, not in a primitive fashion, in a more realistic fashion. Then we are trying to use reinforcement learning. So those type of challenges.
Why simulating? I mean, the design choice of having the full data on all players. Why is it important? What are the consequences of having or not having of making or not making the choice?
Well, many analytics in professional sports are based on a comprehensive understanding of the whole picture of the whole game. So, for instance, you want to compare the amount of the distance that particular player, particular team covered in a particular moment or a game. You want to see the total number of passes, or you want to see the accuracy of the passes. If I'm not calculating 10% of the passes of this particular player, then my metric, successful passes, is not an accurate one. Well, so we have to make sure that we have the coverage. So because without the full coverage, the analytics in sports lose a significant amount of usability, because you cannot just use the data for particular questions and you cannot just run particular metrics.
It is back compatibility with the analytics techniques used in sports.
Yes, it is. It might change, and it probably will change towards more and more, model-based approach, where the model will be the key analytics tool. But let's be realistic. I mean, the business is not saturated by data scientists yet. It's only the beginning. Like, only the first data scientists are starting working in the business. So we cannot expect for the next decade that we will have like a huge shift. It happens, but still we will have people who just want to have the total accuracy of the passes across the season of this particular player, because I want to compare him or her to a potential transfer that I want to make.
Right, and this is extremely important lesson for anyone who's building innovative solutions, that those should plug into the existing ecosystem of tools or methods, techniques used by the industry.
Yeah.
Okay. You're doing quite amazing things with the computer vision. And I'm curious, how did this whole thing started? What led you to focus on sports? And what was the thing, or what was that moment when you said, yeah, I'm doing it as a company?
I came upon the idea when I was working, this idea of implementing computer vision to sports, when I was working in my previous job as a sales guy, chief revenue officer at one of the largest Polish data science companies, but called Deepsense.ai, but specialized in computer vision, especially. So I was responsible for framing, selling, and supervising from the business perspective, because I'm the business guy. I'm not programmer. I hope I understand enough, but I'm not the programmer. So I was responsible for the framing, selling, and supervising computer vision projects for various industries, especially heavy industries such as industrial machinery producing tire manufacturers, car companies, those type of things, where computer vision was successful early on. By early on, I mean computer vision revolution is like 10 years old thing. I mean, yeah, like the things that started to the conjunction of algorithms and compute power happened 10 years ago, 7 years ago maybe, when we had particularly developed essentially neural network based algorithms, computer vision algorithms, and enough compute to actually pull them off. And the GPU revolution, by the way, helped a lot. So the first implementations of such systems were in an industrial environment. Why? Because industrial environment is extremely standardized. So you have a production line. The production line goes same way every single day. The lighting, the humidity, the setup of the work is the same every single day. The positioning of the camera can be the same and nothing will change. So you install the camera, you build the software, and you train the software to detect faults, to detect cuts on the surface of the tire that have been detected by the human watching it and just testing it with his or her hands. So, and it's easy because it's standardized. Yeah. So no surprise, the first huge implementation, huge cost cuts thanks to computer vision were in industrial setting, and we were part of it. I was part of it as a part of this company I mentioned, and I was experiencing the thing that actually made me believe it's possible to implement it to such such an environment as sport was the moment where I realized that a year ago, 15 months ago, I was discussing a much more simpler way or idea of implementing particular system than I was just now. So the progress that happened over just 5 quarters, 15 months were immense. I mean, there were new libraries, there were new approaches, new scientific papers that broadened the scope of what was possible, and it was happening like month to month, essentially. So that made me stop and think, well, if this is the pace of the progress, what use cases are next? And as a sports fan myself, and being quite fluent in what's going on, what's possible, etc., I said, well, it's a huge potential. There's a huge potential in sports. There is probably not that much innovation for various reasons. Therefore, it is ripe for innovation. It is ripe for disruption. And that was the moment that triggered me to start the company.
How did you go about partnering with those first customers to get the data? You said clubs were generous enough to embrace you guys early and share the data with you, but I imagine it still took some time and some convincing on your behalf to make that happen.
Yes. Yeah. Well, it's a funny story because we established the company in February 2020. So literally a week before, let's say, first lockdowns and the outbreak of a COVID pandemic. So it was a weird time where where not many of us didn't know what's going to happen next in a few months, and everyone was everyone was ordered and required to sit at home. We decided that, okay, well, we're going to sit at home anyways. We're going to work remote. Why not try to make some connections with the outside world? And we enrolled for an accelerator. Which sports tech accelerator, and we decided, yeah, well, let's give it a chance. Let's see. Let's talk to potential customers. The accelerator was quite practical. I mean, they not only coached or gave some insights on the business side, but they also allowed you to sell, to pitch to a variety of partners, essentially sports organizations. So we had this first verification of our ideas and our, let's say, feasibility study, because we had just started the company, like we just started working on it. We had this very quick meeting with reality, quick verification. And fortunately enough, that was the moment where we converted our first customer. I mentioned PSG, Paris Saint-Germain was our first customer. They were jury on this accelerator, and that's how we started. And of course, similarly, we expanded the customers, the customer base from there using similar approach.
How many clubs or customers you guys working with right now?
With a dozen or so.
That's a good number. A dozen sport clubs. and not the small ones. As you said, well, that's kind of self-selection because only larger ones were the good fit for the product, but it's remarkable. And in terms of the team, how big is the team?
25 persons.
Okay. Now, when you're growing the team and you're building the company out, what kind of culture, what kind of team you would like to have, and how does it instruct your hiring process?
I do believe that at the end of the day, consciously or subconsciously, you converge to recruit people who are like-minded or like somehow similar to the founding team that started the company. Because you whether you want it or not, to a certain extent, you recruit by comparison, by extension of yourself. So um, we are fortunate to have a quite a sizable team of co-founders, four persons, to strictly technological co-founders to business co-founders. That provides some variety. Well, we are for wild males, so not that much diversity in here, but at least different approaches, different backgrounds, and different strengths, which helps us build a more robust team than just copying myself all over a recruitment process. Having said that, well, that was the first observation. The second observation would be we are quite aware that what we are trying to do is rather difficult than not. It's less copy paste of what has been done in different environment, industry or geography, but trying to push the boundaries of what is generally possible with the technology. Having said that, it's quite important to recruit people who are ambitious and of higher quality, are smart and knowing what they want to do and being able to execute it well. That's why we hire quite slow. I mean, I think compared to market benchmarks, industry benchmarks, it takes us some time to recruit people. We invest some time ourselves. We have no lengthy interviewing process, homeworks, few rounds of interviews, etc., etc. But so far it worked. I mean, we have extremely low churn, extremely low. Like we grew to 25 persons, and the total churn was 3 persons, 4 persons. Of course, that might not necessarily be good, because that might mean that we are unable to cut the bond with the people at the same time. Well, I hope it's not that the case, but I hope it's the other case, that the guys are good and motivated and everyone likes working together, so we stick together and we work together. I do hope that's the case. But having said that, that's something that we decided consciously to maintain, like invest more time, recruit smart, motivated people who are adding something to the work, to the team. And so far we managed to do that. So far we managed to grow from 4 to 25. Hopefully it will last at least for some time. I'm aware that there will be more and more challenges as we scale, but so far it worked.
In terms of the building company so far overall, what would you say, what would be your advice to entrepreneurs starting new companies, starting business, applying AI today? What maybe would you want yourself to know 2 years ago when you were just starting?
Yeah, I think there are two things that I want to mention here. First is give I would advise myself or any entrepreneur doing AI business to think carefully and deeply about the actual technology required to build a product that you envision. So how difficult the technology is, what are the risks and probabilities around it? No, so can you say I'm 98% sure I will build the solution in 6 months, or you will say I'm 60% sure I will build it in 2 years? Yeah, those are like totally different approaches, and they should influence the capital raise decision. They should influence the hiring decision. They should influence the way you set up the company, because right now we are living in a well, this particular moment might not be the best moment, but we're living in a more and more attractive VC environment. By attractive, I mean attractive for founders, attractive for LPs who are pouring more and more money into the asset class, venture capital asset class, but it comes at a price. I mean, it comes at the price of standardization. And the standardization in the VC world means less technology, more productization. And if your product is more of a deep tech variety or high uncertainty around it, think carefully about the type of partners and the type of fundraising you're doing, because you don't want to end up in a portfolio of a VC fund who will use average benchmarks to your deep tech product. Yeah. So that's something that I'm aware right now as a builder of a deep tech solution, which fortunately works and which fortunately generates revenue and sufficient revenue to to maintain the company, etc. But it wasn't always like that, and when I look back and think about the probabilities, it wasn't granted that it would be like that. So for sure, adjust the technology profile to the capital you take and to the essentially setup of the whole company. Maybe it would make sense to bootstrap a little longer. Maybe it would make sense to use angel money, or maybe it will make sense to use VC money very, very early on, because you're almost there, you already have product, etc. It's the timing is very important. It's not that easy that starting a company, I'm raising money, I'm out of money, I'm raising another money. Well, it might be that easy if you are in a bull market, etc. But it's worth thinking and trying to make it work.
Making sure you're properly assess the time it will take for you to build the initial product, get initial traction, get to the stage where you're in a more of a product-led position to raise more funds.
Yes, that is correct. That's quite important, because in worst case scenario, you might have misaligned incentives or misaligned expectations towards the milestones and the development of the company. And at the very worst, you might not be able to realize what you believe is your vision or was your assumption if you didn't prepare the reality, if you didn't prepare the foundations to be aligned with your vision.
Yeah, and as an entrepreneur, it's sometimes real hard to stay your course, stay your direction, and be fully open about how long it will take, because you understand that investors would prefer things to happen much faster. So that might influence how you communicate things to them. But this is dangerous, because if you kind of let them believe that things will happen much faster than they will eventually will, that will create big issues down the road. Okay, so let's switch to the future now and talk about what are your long-term goals for the company? What do you want it to be in the future?
Well, the vision of the company is to be the go-to sports analytics data company. I mean, to be able to obtain the most insightful set of information, set of data from sporting events on various sports, and to give customers, to give interested parties the competitive advantage by using this data. And obviously, we want it to be tech-driven. We envision it to be tech-driven. We envision that the future of the sports lies in technology and ability to leverage technology for the competitive gain. And we want to be the guys, the company that will allow it and will make huge leaps in that. Yeah. So that's the very basic vision. It's an ambitious one, but if you ask about what do I perceive as a success story for the company, that's it. I mean, go to sports analytics data company. Go to, as in, well, everyone should use us because we have the best data. Those are this is the long-term vision. The expansion of this vision pertains to another avenue which I touched upon during this interview, which is visually entertainment dimension connected with bringing immersion to sports, like trying to, maybe it's a bit too big of a word, but heck, I will use it anyway, reinvent the way the sport is consumed. Yeah, trying to open up spectators' minds and experiences by pushing certain approach, certain immersive, innovative, again, heavily leveraging virtual reality and technology approach to sports broadcasting to be a reinvent what it means to be sports spectator. You no longer have to be on the stadium. You can experience it with a high quality technology and hardware. You can experience it from home, and maybe even more immersive fashion. Why not? I mean, it's probably sacrilegious what I just said. Like, how can you be more immersed than on the stadium itself? But maybe in a few years' time, that won't be the case anymore, and the technology will help us in it, and we will also love to be part of it. So those are the long-term goals for the company.
It's interesting to think about that sports are experienced live, sitting at the stadium, not because someone thought, oh, this is probably the best way to experience sports. It's actually because that was the only way to experience sports for centuries.
Yes, it was.
And it means that there is no real conscious decision or real conscious deliberate choice to do it that way. It's just happened. And which means, we can find multiple new ways to experience sports and then make our choices, whether we want to experience them one way or the other.
I would wish so. Yeah, I certainly wish that would be the case, and the technology will play quite important part in it.
Excellent. Pawel, where can listeners learn more about the company? How can they follow you guys?
Certainly, I would like to invite everyone to visit our website, ReSpo.Vision, simple as that. And in order to see the updates and know what's going on in the company, I do believe so. Interestingly enough, that the best way to get a grasp on it would be to follow us on LinkedIn. Again, ReSpo.Vision. At LinkedIn, we do post what's going on about our customers, about the hiring announcements and other business and product announcements. So that's also something that I invite everyone to do. Follow us on LinkedIn and go check out our webpage.
We'll add these links to the show notes. Sounds good.
Thanks.
Pawel, thanks a lot for joining me today. It was a pleasure to talk to you.
It was a pleasure to talk to you, Artem, as well, and thank you very much.